Alright, so number 1. It reads, a teacher upset his student with Snapchat in class, takes the student's phone, and throws it out the window 10 meters a second horizontally. If the phone leaves the window from a height of 11.025 meters, how far away does it land from the classroom? Alright, so let's just draw a picture first before we do anything else. I've got some school here, and I got a window on the side of the school. And that window, from the height the phone is thrown to the ground, is 11.025 meters. Since there's a change in height, we can call it delta y. Now, I throw that phone out the window exactly horizontally at 10 meters a second. Since it's in the horizontal direction, I can just call it v naught x. I don't need to use any sine or cosine on this because it's exactly horizontally. If I take the sine of 0, I get 0. I take the cosine of 0, I get 1, so 1 times 10 is 10. This only works when it's exactly horizontally. If it weren't exactly horizontally, this wouldn't work. Now, as that thing comes out, as the phone comes out, gravity starts to pull down on it. It starts to go faster and faster downward. The acceleration due to gravity only happens in the y direction. It's 9.8 meters per second squared. And we normally put a negative sign there to show it's going downward. So let's try this problem out. Just repeating the variables we know from the first one. V naught x equals a positive 10. V naught y is 0 meters per second. Why is 0? Well, all the energy I can throw is going to exactly sideways, so there's no energy pushing this thing down to start. If you want to think of it like a waterfall, there's no water rising up out of the river before it goes off the edge of the cliff, and none of it's going into the cliff, it's just going sideways, right? So V naught y is 0. We ignore air resistance, which is code for A of x is 0. We know A of y is negative 9.8 meters a second squared. We know delta y, it's equal to 11.025 meters. And we're looking for delta x. That's ultimately our question. To get there, we're going to use time, which we also don't know. Now, to get that time, the easiest thing I can do is use the formula delta y equal v naught y time plus 1/2 a y t squared, or 11.025 equals 0, that's nice, plus 1/2 times negative 9.8 t squared. Sorry, I ran out of room there. So I get 11.025, which is technically negative because it's going downwards, equals negative 4.9 t squared, or negative 11.025 over negative 4.9 equals t squared, or the square root of those numbers, which 11.025 divided by 4.9 comes out to 2.25 equals t, which the square root of 2.25 should be 1.5. Yeah, equals 1.5 seconds. So this thing falls for 1.5 seconds. So basically, I've got my building, and I throw my phone out the window. It starts off going sideways, and as it goes along, it starts to speed up and become more and more vertical, something like that. And we're looking for this delta x. Well, delta x, in this case, in most cases, is just whatever I started off with in the x velocity times the time it takes to fall. And that's because there's no air resistance. The speed doesn't change. That's just coming from the formula delta x equals v naught xt plus 1/2 axt squared. But ax is 0, so this is all that's left over. Anyway, that comes out to delta x equals my starting velocity of 10 times my time, which was 1.5 seconds, or delta x equals 15 meters. Let me check my study guide there, and indeed that's what I wrote down as a final answer. So hopefully that makes a level of sense, and feel free to email me if you have any questions. See you tomorrow.